Hello.
Kaylee, what's up? How you doing?
Good?
Good? Good?
Mm-hmm.
Hey, did you get, is your hair, I'm just kidding. I talked about your hair the last 3 times. Good weekend? Good weekend?
Mm-hmm.
Any jail time? Or was it just a little bit?
None?
That's good. You met your goal. I'm proud of you. Well done. How's mathematics going?
Okay.
Okay.
Mm-hmm.
Any new stuff you want to talk about today?
Can we review chapter 7 again? I keep
Chapter 7.
prolonging the test and then I forget everything.
I hate that, don't you? All right, so let's see if I still have it. Kaylee, chapter 7. I got it. What? And I also have chapter 8, rational functions. Do you skip around?
No, I just have to retake the test for chapter 7 and I haven't done it.
Okay, so I'm wondering if they have a chapter review at the end, because that's kind of tough, right? To do everything, just, jumping from thing to thing. So I think what I'll do, ooh, TAKS, there's a chapter test here and a chapter review. So we'll take a look at that, okay? Sound good?
Mm-hmm.
Right? Okay, hold the phone, check. Almost there, Kales. Let me move this here and this here and here and sharing the screen. So I'm going to share your book so we're both looking at the same thing, okay?
Mm-hmm.
As long and my whiteboard here. And so you should see your book, right?
Mm-hmm.
So I think maybe the test would be better because that has examples and you've seen examples. So look at like 1 through 9 and see what you think about that. This is probably from the first section anyway, if you want to do any of those.
I kind of forgot how to do it.
Okay, so let me get the copy tool. Put it over here and a chunk. All right, so the basic form of any exponential graph, that doesn't look good, does it? Is this. That's the basic shape of y equals a to the x, right? A is some number. And if it's just the a, then it always goes through the point 0, 1. Yes?
Mm-hmm.
Okay. So 3 to the x could totally look like this if I don't have a scale.
Mm-hmm.
Okay. 2 times 4 to the x minus 2 would sort of look like this. Okay. If you ever get messed up, you can always make a table. So let's just make a table for 3 to the x. So x and then y equals 3 to the x, right? So I don't know, do a -1, like just -1. 3 to the negative 1 is just 1 over 3, isn't it?
Mhm.
0, anything to the 0 power is 1, right? So that's this guy. And then what? Negative 1 is 1/3. So maybe that's okay. And then when it's 1, then the answer is 3. So 1, and then this would be at 3, and so on, right? And you can
Mhm.
get the basic shape. So now what they're trying to do, like for number 2, y equals 2 times 4 to the x minus 2. So let's have a look here. So if you just, they're trying to get you to think of the basic curve and how to adjust it. So I don't know, that's y equals a to the x, let's say, right?
Mhm.
Y equals a to the x. Well, the x minus 2, since the minus 2 is with the x, is going to move the graph 2 units to the right. It's always the opposite sign when it's with the x. Okay, or it's the opposite of the sign, I should say. Since it's minus, then this point, all the points are going to move 2 units to the right. So like 1, 2. So this point at 0, 1 is going to move 1, 2 units to the right and be at 2, 1. Okay, so the entire graph shifts that way. But the 2 in front, that means it's going to be steeper. It's going to go up a lot quicker. And maybe since once you move this, maybe you think, okay, let's go ahead and plug that in there and see what the 2 does to it, right? So if x is 0, right, then what's y? Well, 2 times 4 to the x minus 2, 0. Actually, let's plug in 2. Sorry, let's plug in 2 because that's what moving it 2 does. Moving it 2 units to the right does. So if x is 2, then it's 4 to the 0 power. You see what I'm saying? 2 minus 2, which is 1, and 2 times 1 is 2. So because of the 2, which I'll put in green, wonk, that moves a point up another one. Okay. And then let's try 1. We're just trying to get a decent shape. I think the table will really help you. So if x is 1, right? So that becomes 2 times 4 to the negative 1, right? Which is 2 times 1/4, which is 1/2. So we get 1/2. So like here. So we have a pretty good idea of what's happening here just with these 2 points. And I'll do the final graph in green because we've got this and we've got this. And you see how it's shooting up a lot quicker. And we know it's going to hit down here. And then we would just do something like that. You okay?
Yeah, I'm just writing it down.
Okay.
Okay.
Okay. So let's look at number 3. That's a good one. Let's see. stupid. Okay. All right, let's see. So for number 3, what is the negative going to do?
Flip it.
It certainly is. So it's going to go from here, and it's going to look like this. Okay. And then it's going to, because of the +3, that means it's going to move left 3, right? The opposite sign. And when it's outside, this +3 means it's going to move up 3. And then the -5 is going to like kapow. It's gonna wreak havoc on it. Okay. And so that gives you a general idea. And I always feel like with these, you really need a table. So let's do it. And I'm always going to start with what's going to make the guy 0. So up there in the exponent. So I'm going to start with -3. Okay. Because if I plug in -3 for x, I get 2 to the 0. Is that cool?
Mm-hmm.
Okay. So -3, 2 to the 0 is 1, times -5 is -5 plus 3 is -2. All right, -3, -2. I get that. Okay. So let's just start putting in some points here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3. Just because it's going to get a little dicey. 2, 3, 4, 5, 6. So 5, 5, -5, -5, whatever. Okay, so -3, 2, -2, sorry, -3, -2, boom, right?
Mm-hmm.
Okay, and let's do some easier ones because this -5 is just horrific, isn't it? So maybe we do -2, because that would be 2 to the 1st, right? -5 times 2 is -10 plus 3 is -7. So -2, -7, that's down here. So we kind of see what's happening, right? Because we knew that the original guy looks like something like this, right? So we can kind of start seeing the mirror image happening. Yeah.
Mm-hmm.
Okay, and so let's just take a -5 just for kicks, just to see where it goes. Just for kicks, not just for kicks. -5 plus 3 is -2. So it's 2 to the -2, -5 times 2 to the -2 plus 3. So that's -5 times 1/4, right? Okay, plus 3. So that's -5/4, which is -1 1/4. Are you okay with that? Plus 3. So I know it goes above, right? It certainly goes above, and that's because of the plus 3 thing. And that's what, 1.75 at -5. So somewhere around here. So now we have a really good idea of what this thing looks like. Okay.
Mm-hmm.
Does that kind of help?
Mm-hmm.
Now E is about 2.78, right? A base of E, that's like 2.7. So if you want to get some estimates of points, you can use 3 for E, right? Now it's not exact, so you got to compensate a bit, but at least it gives you an idea of the shape of it. All right.
Mm-hmm.
Okay. So let me switch over here. Why did that happen? Okay, what about evaluating the logarithm? Remember how to do these guys, 10, 11, and 12?
I forgot.
5, this is a question. Log base 5 of 25 is asking 5 to what power is 25?
Oh, 2.
So log base 5 of 25 is 2, right? That's the basics. Okay, so what you do if you can't really solve it like we just did, just by looking at it, is you change it to exponential form. 5 to the x equals 25, and once you solve that, then you know you get the log base, you get the value of the log. It's 2. Okay, so if I go x here, 2 to the x equals 1 over 32. So what we need to do is get the same base. So can't I write 32 as 2 to the 5th power? No? Yes? Okay. And then since it's in the denominator, can't I move it to the numerator like this? So x equals -5, meaning log base 2 of 1 over 32 equals -5.
Is it 0?
Yay! Good. All right, so logarithms are the inverse of the exponential functions that we just graphed. And this one you really need to do by transformations, okay? Because we can't do the logs in our head. So it looks like, so the inverse is like, or I'm sorry, the exponential is like that. If it's an inverse, it's the reflection in the line y equals x. So 0, 1 becomes 1, 0. And this is your basic graph of y equals log x, like this, okay? Okay, so I'm going to get rid of this other stuff and just put in this basic shape. And that's what we're going to base everything on, okay? So y equals log base 2 of x, this is perfectly fine, right? This is actually a little slimmer or a little shorter. I should make it a little closer to the x-axis. I got a little excited. This is 1. It's a slower climb, whatever. So with log base 2 of x, you can still, like for something like this, you could make an xy table, right? Like 1, when x is 1, 2 to the what equals 1, well, it's 0. And you want to get something nice, like if x is 4, then y would have to be 2. Because 2 squared equals 4. So like 4, 2, right? Something like that. Basically, if you just have log base anything of x, you can just draw this and put the 1 and be done with it. Okay. And they're not going to do that much to you here. Okay. As far as anything real complicated, because they know you can't do natural logs in your head. Okay, so let's go duplicate that and we'll go to here and I'm going to get rid of this junk. Okay, so let me get this. Okay, so natural log of x, same thing. It's going to go through 1, 0. But what does this -3 do to it? Outside of the x. It's not in parentheses with the x.
It goes down.
There you go, down 3. If it was like this, Kaylee, if it was like that, it would be to the right 3.
Mhm.
Okay. So all we have to do is move this guy down 3, right? So I'm going to duplicate it. I'm going to make it red because that's how I roll, right? And if it goes down 3, I would say, okay, 1, 2, 3. I would look at this point right here and just move it down 3 and then copy it as best I could. Of course, you're not going to be as good as me, but you know, then again, who is, right? And it would look like that. Is that okay?
Mhm.
And then this is like, you don't have to put this function on there. You can, but that's what it looks like, okay?
Mhm.
Okay. All right, and what the heck is this one gonna do? What does this +3 do right here?
Left 3.
Good. And what's the +2 do?
Up there 2.
Up 2. So I gotta go left 3, 1, 2, 3, and up 2. 1, 2. So I'd go ahead and put that point there. This the intercept, right? 1, 2, 3, 1, 2. Boom. Right? So what we haven't been doing is naming the domain and the range. I didn't see that. I just saw that till now. So just plain old log x, the domain, do you see it's x greater than 0?
Mhm.
And then the range is all real numbers. I guess you could do -infinity less than y less than infinity. I can't remember how your teacher has you do it. Or -infinity, comma, infinity, like that. Because it goes all the way down and all the way up. You okay?
Mhm.
Okay, so if we duplicate that, make it red, and we're just going to take this graph, we're going to move it left 3 and up 2, and it looks like that, right? So now the only thing that's going to change is the domain, because it used to be greater than 0, right? And this is f of x equals log x plus 3 plus 2. So what's the domain now, Kaylee?
X is greater than 3.
-3.
Oh, -3.
Yeah, because here the 0 is an asymptote, it's not going to cross it, and this 2, and the range is always going to be the real numbers. So -infinity to infinity. It's the same idea with the exponential graphs. Ow. How we doing?
Good.
All right, let's have a look. See. Condense the expression. How we doing on time? All right, halfway through, not too bad. We've got a lot done. Now, I gave you all these rules, Kaylee. Do you remember that? The logarithm rules?
You froze. What did you say?
I gave you the logarithm rules. Do you remember?
Uh-huh.
Let me see if I got them. I think I do. Ah. All right, here they are. Can you see them okay?
Mm-hmm.
Okay, so that means they want to write it as one logarithm. So we're going to use this one first and rewrite this as ln of 7 squared minus ln of 4 cubed. So that's the one where you can take the coefficient and write it as an exponent.
Mm-hmm.
So then this would be ln of 49 minus ln of 64. And then I'm going to use this rule. Ln of 49 over 64. And we can't simplify that fraction. So we're good. Nothing I can do with the first one, is there?
Mm-hmm.
What can I do to the second one?
Log 2 to the power 5.
Yay. And what is 2 to the power 5?
32.
Good. And then we have the addition formula, right?
Mm-hmm.
So that becomes 3 times 32, which is log base 3 of 96. Is that fair?
Wait, well, how did it turn into log base 3?
I'm sorry.
How did it turn from log base 4 to log base 3?
Oh my God, look right behind you. There's a spider. There's a giant spider right over your shoulder. Look, quick, quick, look, look, keep looking, keep looking, keep looking, keep looking. I'm sorry, what was your question?
Never mind.
Yeah, I thought so. Asking me questions like that. Thank you for catching it.
No problem.
Okay, sorry about that. All right, so log base 5 plus log x equals log of 5x, doesn't it?
Mhm.
And what can I do with that too?
Log 3 squared.
Good. So that's log 5x minus log of 9, isn't it?
Mhm.
And then we use the subtraction and we can do that. Yes?
Yes.
All right. All right. So let's see what we got here. Change of base. Okay, let's get our rules, which I guess you're gonna have to know, right?
Mhm.
All right, so change of base, where is that? It's not there. So what change of base says is that log base A of B can be written as log base C of B over log base C of A. In other words, we can choose any new base that we want. Okay.
Mhm.
All right. So this equals log. I'm just going to write 50 over log 5 for now.
I got it.
I know. I'm just thinking. Okay. And what I think. Okay. What I think we should do is leave it as base 10. And I had to think ahead 2 steps here because I was thinking, well, there's nothing to a power that gives me 50, right? So that's no good. But can't I write log 50 as log 5 times 10? Does that make sense?
Mhm.
Which then equals no. Let me take a quick look at something here. I'm not sure how they do this one. Oh my God, they're talking about using a calculator. That's so stupid. Okay, so you just change it to base 10. I'm sorry, Kaylee. Actually, I'm not sorry. That's just really dumb. Why would you do that when you can put in the log for the calculator all by itself? But who am I, right? I thought you had to do these without a calculator. So all this means is you write it like that, and then you take log of 50 divided by log of 5 on your calculator using the change of base. So they both have a base of 10, right? So log of 23 divided by log of 6, whatever the decimal is. Log of 45 divided by log of 9. They're assuming that you don't have a way to change the base on your calculator, and it just depends on what calculator you have. Okay. All right. Okay. So now what are we doing? Solve the equation. So this is a big skim over review, Kaylee, right? This is giving the basics. It's hard to review an entire chapter in an hour, right? So I would take a look, look at the, and when we're done, I would look some more at the exercises from the chapters and go through and do a bunch of those. All right, so anytime you have the variable and the exponent, you're going to use logarithms. You're going to take the logarithm of both sides. Okay, so we will do log of 7 to the 2x equals log of 30. Are you okay with that? Now, the idea is to get the variable out of the exponent. And so the whole reason we do that is because of one of our favorite rules right here. Because if it's in the exponent and I have it's a logarithm, I can bring it down in front as the coefficient. Are you okay with that?
Can you explain it again?
Okay, so do you see this rule right here where the k is an exponent of the logarithm? And then if it is, and then you can move it from the exponent to be a coefficient of the logarithm. So 2x is the exponent, so I just moved it out in front because of this rule. You all right? Okay, so I'm solving for x and everything's being multiplied by here. So I'm going to divide by 2 log 7. Because this cancels out, right? So x equals log 30 over 2 log 7. And then we would put that in our calculator. And I get 0.873. When I put it in my calculator. Or 874 if I round it correctly. Okay. You ready for the next one?
Mhm.
So this is a coefficient here, right? And the x is in here. So I'm going to get rid of that coefficient by dividing both sides by 3. And that would give me log of x minus 4 is equal to 2, correct?
Mhm.
So now I'm going to go from logarithmic to exponential form. And that would mean I take the base, which is 10, and say 10 squared is equal to x minus 4. Well, now we just solve, right? 100 equals x minus 4. 104 equals x. And what do you think we should do for number 24?
Divide by, no. Multiply it first.
I think you mean rewrite it like this, x times x plus 6.
Mhm.
Atta girl. Equals 2, right?
Mhm.
Now what should we do? Since we have one logarithm and it's equal to a number.
You also log it.
Well, no, then I would have to take the log of a log on both sides. So if I have the log of something equal to a number, I should write it in exponential form, because if I do, it's the same thing that just happened over here. 4 squared equals x times x plus 6. Do you remember how to go from logarithmic to exponential back and forth like we've been doing here?
Kind of.
Okay. You need to have all these rules. They're in your book, right? But you need to get them down on one piece of paper. Here, let me bring this up. Here it is. So this wasn't on your sheet, but here it is. It's the fundamental thing, right? So we had like log base 4 of x plus 6 equals 2. So we're in this form right here. And so we went from logarithmic to exponential. So that's what happened. So now we have 16 equals x squared plus 6x, right? And so it's a quadratic, so we're going to get everything on one side. Yeah. And then we try and factor it, but we can't, can we? I don't think we can, unless you see something that I do not. Factors of 16 are 1, 16, 2, 8, and 4, 4. So we're gonna have, what are we gonna have to do to solve this? Quadratic formula. X equals negative b plus or minus the square root of b squared minus, remember this one?
I forgot what that was for a second.
You okay now?
Mm-hmm.
Okay. So that's going to be negative 6 plus or minus the square root of b squared 36 minus 4 times 1 times 16 all over 2a, or 2 times 1. So x equals negative 6 plus or minus the square root of 36. 4 times 16 is 54. So 36 minus 64 is negative 28 over 2, which means we have no solutions. Why is that? Oh, you know what? Maybe we do. I'm sorry, Kaylee. This isn't plus 16. This is minus 16. This is minus 16. But if we got a negative on this under the square root, you can't take the negative of the square root or the square root of a negative. So that's why there would be no solutions. But this is a minus 16, which is going to change this. You're supposed to yell at me when I do something like that, Kaylee.
Oh, I didn't notice.
Well, I blame you for all of my mistakes. Is that okay?
Yeah.
Okay. So negative b is negative 6 plus or minus the square root of b squared 36 minus 4 times a, which is 1, times c, which is negative 16, all over 2 times 1, right?
Wait, can't you just factor it? Isn't it?
Now you
X-
can. Yep, 8 and 2, now that it's minus.
Is it just x equals 2?
Yes, why?
Because x would be negative 8 and you can't have a log of a negative number.
Correct. And you have to make sure you look, because the inside of a parentheses could be such where negative would work, right?
Mm-hmm.
So be careful. But yes, you're correct. Good. Okay. So let's try 25. And I'll put 26 up at the same time. How's that? It'll be great. Wow. $25. Y equals AB to the X. Okay, and it goes through -148. I'm going to put them down along here. -148 and 26. Yeah.
Mhm.
Well, that means we can plug them in because I need to be able to find A and B. Is that okay?
Mhm.
Okay, so if I plug in -148, I get 48 equals A times B to the -1. Is that all right?
Mhm.
If I plug in 6, 2, I get 6 equals A B squared. You okay?
Mhm.
Okay, so now I got a system of equations, so I have to solve for one and put it in for the other, right? So I don't know, I'm not going to deal with the negative exponent just yet. So I'm just going to divide both sides by b squared here. And do you see how I get 6 over b squared is equal to A?
Mhm.
So then I'm going to plug that into this equation for A, okay? And I get 48 equals 6 over b squared times b to the -1. You all right?
Yeah.
So then do you agree that 48 equals 6 over b? Simplifying the exponents. 48b is equal to 6. B equals 6 over 48. B equals 1 over 8. Is that all right?
Mhm.
Now we know that A equals 6 over b squared, don't we?
Mhm.
So then we can use that and say that A equals 6 over 1 over 8 squared equals 6 over 1 over 64 equals 6 times 64 equals 384. Meaning we get y equals 384 times 1 over 8 to the x. You okay?
Mhm.
All right, Kaylee, that is a whole lot of stuff. And again, it's like the underlying thing. So I would go back through as much as you can. When's your retake?
I don't know. I can take it anytime I want. I keep trying to do it like I keep saying I'll do it this week, but I keep procrastinating.
Not a good thing. Do you have your old test?
I think I sent it to you a couple weeks ago.
Okay, do you still have it?
I have pictures of it.
Okay, so if you really want to do it this week, maybe you should go back and make sure you can do everything on that test
Okay.
on your own, even the ones you got right, since it's been so long. And I remember
Mhm.
going over it with you. So there should be notes somewhere from me. And then if you can't do everything, then see if mom will let you have another session with me sometime this week and we can get that answered and then you can get it out of the way. That'd be a nice thing to get out of the way, wouldn't it?
Mhm.
Okay. So I will wait to hear from you. And I have a video. Do you want me to post a video of this?
Sure.
Okay. And do you have the link to your folder? I'll send you the link to your folder. I know I have a folder for you, but then you can use that folder from here on out for all of the videos, okay?
Mhm.
All right, I will wait to hear from you. And if I don't, then I will see you in a week, okay?
Okay.
What's your goal? Don't,
Don't procrastinate.
not, I mean, don't say something that's not correct. What's your goal?
Don't say something that's not right. um, don't fail my math test. Don't go to jail.
Stay out of prison. Good. All right. See you on Tuesday or earlier.
Okay. Bye.
Bye.